Hi everyone, my name is Matt, also known as UKAstroNut, and in this video I'm going to talk to you about the nucleus of atoms. So the nucleus is the centre of an atom. Just as the sun is the centre of our solar system and we have planets going around the outside, in the atom the nucleus is the centre and the electrons are the thing that are whizzing around the outside. So what is the nucleus made of? Well, on a basic level, the nucleus is made of things called neutrons and protons. So these are two of the sort of bigger particles that there are. And these are also made of much smaller things, which I'll go into detail in more videos. But these are just two separate particles. They're very similar to each other in mass, so how much they weigh. The neutron is sort of neutron-neutral is the way you should remember it. It doesn't have a charge. So this means if you have like a magnet, so a magnet has a positive and a negative end, which is magnetized. So you can put the minus and the plus of a magnet together and they attract, and then a plus and they repel each other, negative and negative and repel. So this is the same kind of way. A neutron doesn't have any kind of charge or any attraction to anything else, whereas a proton is positively charged. In comparison, an electron is negatively charged. So theoretically, protons and electrons are pulling together towards each other and attracting together, whereas a neutron sort of doesn't do anything. It doesn't attract in that kind of way with anything. But the protons and neutrons are actually held together in the centre by something called strong force. So this is some fundamental force of nature, like gravity. It's the same kind of idea as gravity. So gravity holds me and you to the Earth, and the strong force, the nuclear force, holds protons and neutrons together. So it works on very, very small distances and it holds these particles close together. Now, what kind of size is what kind of size are we talking about when we talk about the nucleus of an atom? Well, an atom overall is around 10 to the minus 10 meters. So it's like 10 zeros and then a 1. Okay, but if you look at the nucleus, it's even smaller than that, because a lot of this distance is empty space. You have the electrons really far out here, and then right in the centre is this nucleus. So the size of the nucleus is actually 10 to the minus 15 meters. So it's sort of just 15 zeros and then a 1. So it's really, really small. In fact, I have a board here I can show you quickly. So this is what the nucleus might look like with neutrons and protons and these wheelie lines in between the forces that hold all of them together inside the nucleus. And here we have the size of it is around 10 to the minus 15 meters, and that's 0.0000 and zero, loads and loads of zeros, and then a 1. And that's the size. I mean, the human hair is nothing like this. It's much, much bigger than human hair. And the human hair itself is made up of atoms. So this is the kind of size scale that we're talking about here. Its mass, well, the mass for a single proton is around 1 times 10 to the minus 27 kilograms. So that's like 27 zeros and then a 1. It really, really doesn't weigh anything. So you imagine if you had, in this case you have, 4 protons, and neutron weighs about the same. So you have about 8 times 10 to the minus 27, or nearly 1 times 10 to the minus 26 kilograms, but still very, very small. Now, the number of protons and neutrons in a nucleus, well, number of protons determines what element you're looking at. So an element is things like carbon, oxygen, nitrogen, hydrogen, helium, silver, plutonium, lead. All these sort of materials, when they're fundamental, they're not made of things together. They're on their own. They're things called elements. And the number of protons that are in the nucleus determines what element you're looking at. So the element with 1 proton, if you just have a single proton with an electron going around it, that's a hydrogen atom. If, for example, you have here 8 protons, you have oxygen. In oxygen, most of the time, there are 8 neutrons. But the number of neutrons can actually vary. You can actually have different number of neutrons than protons. As you can see here in silver. So silver has 47 protons, but 61 neutrons. And they can have a different number of neutrons and can still be silver. It can still have 60 neutrons, but as long as it has 47 protons, it's always silver. And the number of electrons, for interest, is normally the same as the number of protons, but it can also change. So what element you're actually looking at depends on the number of protons here, not actually on the number of electrons and number of neutrons. Now in all cases, most elements have neutrons, apart from hydrogen, where hydrogen is just a proton at the centre, and an electron going around the outside. But actually, Most other elements also have neutrons and protons, and most of them, well, a lot of them have more neutrons than they do have protons. It just seems to be the way it kind of goes. So you may have heard of something called an isotrope. So an isotrope is something where you can have a certain number of protons in an element, but a different number of neutrons. So we go back to our example of silver, where we had 61 neutrons. If you have 60 neutrons, or you have 62 neutrons, it's still silver, but they're different isotopes, what they're called. An isotope just means it has a different number of neutrons to it. So the largest stable atoms, here we got to a number of 47 protons, but the largest ones have sort of 82 protons, and they're really high number of protons, and these are big particles, and this is just the stable ones. So when you can go up to 82 protons, which is lead, and lead is happy, it can stay where it is and it'll stay as lead. But as you increase more and more, what happens is these things don't like being so big. They don't having this many protons and neutrons, and so they actually decay down to small particles. They decay down to things like lead, and so they basically lose their protons, their neutrons, and electrons, and they go down to smaller atoms, small elements. And this is basically how radiation works. So radioactive material like plutonium and things, they're radioactive because they're basically releasing these particles, this energy, so they can become smaller into a more stable kind of position. So this is a lovely little video telling you about the nucleus of atoms, and this is sort of the core, the centre of everything. And then, as I said, we have electrons around the outside, and this idea of an atom, and atoms build up everything. Atoms form together and stick together, and they build up harder and harder structures until you make this pen. This pen is made of billions and trillions of atoms, but then such a very small scale, and they're all stuck together. But equally, everything else is a piece of paper, which is so different, or water is so different from this pen. This pen is hard, but liquid water is flow and moves. But they're also made of atoms, but they're just in different configurations, they're different atoms and different elements. So this is kind of the fundamental for a lot of physics. But beneath this, each of these neutrons and protons are made up of different particles themselves, and they're held together by different forces. And what are these different forces? The strong force, the nuclear force. What are all these things? Well, hopefully in the rest of this playlist, the rest of these videos, I'll try and explain a little bit more what they are. And I'll also go into things like the electron, and a lot of things about chemicals and elements and things like this. And I'll try and give you a brief overview of what particle and nuclear physics is, I hope, anyway. Thank you very much for watching. Don't forget to check out the rest of my videos, and I'll see you guys soon.